I'm very much sure, friends, that all of us know that e raised to the power x and the natural log of x, guys, are never friendly functions, right? So, friends, the goal of this video today is to create some friendship between the graph of e raised to the power x and the natural log of x. So, guys, as you can see on screen, guys, the graph of e raised to the power x and the natural log of x never intersect each other, right? In fact, even the graphs do not even occur to be tangents to each other at any point. So friends, our goal of this video today, like I said, is to create that friendship, namely by pulling off one curve such that it intersects the other at one point. So guys, in this video, we shall be shifting the graph of e raised to the power x to intersect the graph of the natural log of x at one point as we have on screen. Great. Okay. Now guys, we are going to somehow draw e raised to the power x. We are going to use a constant which is going to make that happen for us. Let's call that constant s. It therefore means that we are going to have this equation being the same as e raised to the power x minus s equals the natural log of x. Like I said, guys, the constant is simply s. So we have to shift this function, this graph, to intersect this graph using some constant which can call that s. Now, guys, if you look at the graph on screen, guys, you can also discover that in as much as the two functions are equal to each other at that point s, their derivatives at that point are also the same as each other. So in this case, guys, when we differentiate both sides, let's call this equation 1, guys. We differentiate both sides, we are going to have e raised to the power x minus s, because we differentiate e raised to the power x minus x, we have e raised to the power x minus s. Differentiating ln x, guys, we have 1 over x. Okay. Now, guys, let's call this equation 2. At this point now, all we need to do is to solve for the value of x. But in this case, guys, we cannot solve for the value of s without finding what x actually is. So in this case, guys, we are going to solve the two equations simultaneously. We have e raised to the power x minus s equal to ln x. This other way, we have e raised to the power x minus x equal to 1 over x. If we equate these two together, we are going to have natural log of x equal to 1 over x. If we cross multiply both sides, we have x ln x equal to 1. At this point now, guys, we are going to look at x as e raised to the power the natural log of x, and we take the Lambert W function on both sides. If we do that, guys, we have w of the natural log of x e raised to the power ln x equal to w of 1. In this case now, guys, the w function simply helps us to bring forth just the output whose exponent is ln x, and the function multiplying the entire e raised to the power ln x function, because this our w function, guys, simply wants that what has to be here, namely ln x, has to be the same as e raised to the power what is also here, which has to be the same as what is multiplying the e raised to the power function. So in this case, guys, our output simply becomes the natural log of x. On the right hand side, we have w of 1. If you solve for x now, guys, we have x to be the same like e raised to the power the Lambert w function of 1. That is when we raise both sides to the power e. Okay. Now that we have the value of x, guys, all we need to do now is to substitute e raised to the power to substitute x equal to e raised to the power w of 1 now into this expression. When we do that, guys, and we take the natural log on both sides, we have e raised to the power w of 1 minus s equals the natural log of w of 1. Note, friends, that we have done two steps at the same time, namely, after putting our x equal to e raised to the power w of 1, we also take the natural log on both sides to clear one of the e's. So we have the natural log of w of 1. In this case now, guys, if we carry e raised to the power w of 1 to the right hand side and we multiply both sides by negative, we are going to have s to be the same like e raised to the power w of 1 minus the natural log of w of 1. Great. So guys, this is the value for s. But first, as you all know, guys, this our expression is unreasonable, right? In the previous video, guys, I didn't give an expression for what I was talking about. But friends, in this case, guys, I think giving us a decimal approximation, guys, will mean a lot, guys, right? Good. All right, let's see, guys. If you go to work from alpha, guys, we are going to see that this guy is approximately about 2.33067, that is to 5 decimal places. Okay, now, guys, this is it for the video, guys. Let's have the graph when you use the value of x, guys. This is how it looks like. Great, guys. Do you see that the two curves now touch each other? Like they are now acting as tangents to each other, right? Great, guys. That's it for the video. Make sure you subscribe to this channel, guys, to have more content from us, guys. Have a blessed day.